in the question it is given that x equal to r cos theta and y equal to r sin theta, and we have to prove Jacobian of r theta with respect to xy multiplied by Jacobian of xy with respect to r theta is equal to 1. We have to prove it. And from the definition of Jacobian, we know Jacobian r theta with respect to xy is equal to the partial derivative of r theta with respect to xy, and in determinant form it can be written as partial derivative of r with respect to x into and partial derivative of r with respect to y, the second term. Similarly, in this row, the first term is partial derivative of theta with respect to x, then the second term will be partial derivative of theta with respect to y. And it is given that x equal to r cos theta and y equal to r sin theta in the question. So r square will be equal to x square plus y square. Because if you take x square plus y square, this will be equal to r square cos square theta plus r square sin square theta. And if you take r square common, in the bracket you have cos square theta plus sin square theta, which is equal to 1. So that will be equal to r square is equal to x square plus y square. And if you take the partial derivative of both the sides, for the left hand side the partial derivative of r with respect to x will be 2r partial derivative of r with respect to x, that is equal to, in the right hand side, that is equal to 2x. Partial derivative of x square is equal to 2x, because partial derivative of y square with respect to x will be equal to 0. So partial derivative of r with respect to x is equal to x by r. Similarly, if you take the partial derivative of r square is equal to x square plus y square with respect to y, for the left hand side the partial derivative of y square with respect to y will be equal to 2r partial derivative of r with respect to y, and for the right hand side the partial derivative of x square with respect to y will be equal to 0, and partial derivative of x square with respect to y will be equal to 2y. So partial derivative of r with respect to y will be equal to y divided by r. So you have first you got the two terms, partial derivative of r with respect to x, which is equal to x by r, and the second term partial derivative of r with respect to y, we got it, that is equal to y by r. Now we'll find out partial derivative of theta with respect to x and partial derivative of theta with respect to y. And in the question it is given that x equal to, you see it is given x equal to r cos theta. Okay, x equal to r cos theta and y equal to r sin theta. So if you divide y by x, that will be equal to r sin theta divided by r cos theta, r cancels, so tan theta. So tan theta will be equal to y by x. So if tan theta will be equal to y by x, theta will be equal to tan inverse y by x. Now we'll find out the partial derivative of theta with respect to x and partial derivative of theta with respect to y. So taking partial derivative of theta with respect to x, then partial derivative of theta with respect to x will be partial derivative of tan inverse y by x, that is equal to 1 divided by 1 plus y by x whole square, and derivative of y by x with respect to x, that is equal to minus y divided by x square, and that is equal, this is simple derivative of the inverse function, tan inverse function, that is equal to, if you solve it, that will be equal to, in the numerator denominator you have x square, so you take it now to the numerator, so x square divided by x square plus y square into minus y divided by x square cancels, so that will be equal to minus y divided by x square plus y square, which is equal to r square. Similarly, you can also find out the partial derivative of this theta with respect to y. So partial derivative of theta with respect to y will be equal to, if you from the definition of the integration of the derivative of the tan inverse function, that is equal to 1 divided by 1 plus y by x whole square, and the partial derivative of y by x with respect to y will be equal to 1 by x. So if you solve it, x square will go to the numerator, x square divided by, in the denominator you have x square plus y square into 1 by x, so x cancel, so this will be x divided by x square plus y square, and x square plus y square is equal to r square. So now you have partial derivative of theta with respect to y, partial derivative of theta with respect to x, and partial derivative of r with respect to x, and partial derivative of r with respect to y. Now you put the values in the Jacobian. So Jacobian r theta with respect to x, y will be equal to x by r, and this is your partial derivative of x with r with respect to x, and this value we have got partial derivative of y with respect to y, and this is partial derivative of theta with respect to x, and this is partial derivative of theta with respect to y. So x by r, y by r minus y by r square, x by r square. So you take the, if you take the determinant, this will be x by r multiplied by x by r square. So this will be x square divided by r cube, minus again a minus plus. So y by r into y by r square, that is equal to y square by r cube. So if you add it in the LCM, you have r cube. So in the numerator you have a square plus y square. A square plus y square is equal to r square. So r square divided by r cube, that is equal to 1 by r. So we have found out the Jacobian of r theta with respect to xy. Now we'll find out Jacobian of xy with respect to r theta. So Jacobian of xy with respect to r theta is the partial derivative of xy with respect to r theta, that is equal to partial derivative of x with respect to r, determinant of partial derivative of x with respect to r, partial derivative of x with respect to theta, then partial derivative of y with respect to r, partial derivative of y with respect to theta. And it is given that x equal to, you see, x equal to r theta, sorry, x is equal to cos theta. So what will be partial derivative of x with respect to r? That will be equal to cos theta. So this is cos theta, then partial derivative of x with respect to theta will be equal to minus r sin theta. So minus r sin theta, then partial derivative of y with respect to r. Here you see y equal to r sin theta. So partial derivative of y with respect to r will be equal to sin theta. So here sin theta, then partial derivative of y with respect to theta will be equal to r cos theta. So here r cos theta. So you have to find out this determinant, that is cos theta minus r sin theta, and cos theta. So if you find out the determinant, here I have written the value of partial derivative of x with respect to r, which is cos theta. Here I have written partial derivative of x with respect to theta minus r sin theta. Okay. And partial derivative of y with respect to r sin theta, what I have told you, and partial derivative of y with respect to theta, that is equal to r cos theta, I have written here. So if you solve it, you see cos theta into r cos theta, that is equal to r cos square theta, plus, because of you have a minus, so minus minus plus, so r sin theta, so r sin square theta. If you take r common, cos square theta plus sin square theta is equal to 1. So this will be equal to r. So if you multiply the Jacobian r theta with respect to xy with Jacobian xy with respect to r theta, previously we have found out Jacobian of r theta with respect to xy equal to 1 by r, and here we have found out Jacobian of xy with respect to r theta is equal to r. So if you multiply 1 by r into r, that is equal to 1. So in this way you can find out, prove that if x equal to r cos theta and y equal to r sin theta, Jacobian of r theta xy into Jacobian of xy r theta is equal to 1.